All right, good morning. I was planning on taking the contest 277 this morning. I didn't do it yesterday, so I didn't do it last weekend, so I was gonna do it virtually today, and then yeah, just do some audio. So we'll see how it goes. Got my my coffee, so let's do this. Alrighty, open these up. The number of elements of both strictly smaller and strictly greater element appear nums. 3 has -3, smaller than it, and the element 90 greater than it. Two elements having both strictly smaller and strictly greater element appear in nums. Okay, so I think we want everything in between the middle, right? Everything besides the endpoints? I think so. Okay, so let's just do this. Let's sort it. Okay, so we got our vector. We'll do sort. That began. That end. Oop. Okay, and then we can use a map to count these things using map on our map. All right, so count each of the elements for auto x and a plus m sub x. And then we can do for auto x in vi a dot began. Let's see, let's do next a dot began, and then previous a dot end. And then we'll accumulate the total, right? Count equals 0, count plus equals m sub x, return count. Does that work? Oops. Hold on, map m. And then also, actually, we want to exclude, right? Let's just exclude. Oh, okay, how about this? Let's do this. For auto x count, oops, hold on. Let's do total. How about in here? Okay, t is okay. T will be our total count. And m, if x does not equal a sub 0 and 10 equals data size. X is not the first or the last element of a, then we can include it, right? So total plus equals the count of that element. Okay. Something like that. Okie dokie. Run that. It should be 2 and 2. Yay. Okay. Rearrange the elements by sign in a 0 index integer array nums of even length, consisting of an equal number of positive and negative integers. Rearrange the nums to be modified as follows. Every consecutive pair of integers have opposite signs. Okay, so plus negative, all integers at the same sign, order in which they are present is preserved. Okay, the rearranged array begins with a positive integer. Return the modified array after modify. Okay. So rearrange it, keep them in place. Okay, so if we keep them in place, basically we can just use 2 queues is what I'm thinking, and then alternate between those queues, right? All right. Oop. There we go. Return a vector of integers. Take a vector of integers as reference. That's the input. Okay, so we want 2 queues, right? q equals q, and so we can do this q a, or how about let's do positive and negative. How about q negative for auto x and a. If x is less than 0, then positive dot push x. And then for the opposite case, we could just do an else, but I don't know. I think this looks nice. So x is, this should be negative. This is positive. Okay, and then for, let's do this. Right, just iterate through this thing n times. Right, so for auto I, 0, I is less than n. Okay, and then we can do, let's formulate the answer, right? VIANS, turn the answer in the end, and then if I and 1, this will be odd. And is that pushback? Oop. So that'll be negative, right? Negative front, neg dot pop. Otherwise, push back onto the answer. Oh, yeah, this should be okay. Push back, positive. I think that works. Let's see what happens. 3, negative 2, 1, negative 5, 2, 4. Okay, and then let's make sure the other one works okay. Looks good. Yay. Okay, find all only numbers in an array. Okay, this one we can just use a set, right? It appears once and there's no adjacent neighbor. All right. Using set, another set. That'll be set S of all the elements. Okay, and then we'll do this VI answer, and then we'll just iterate through them, right? For X in the set, if S dot find X minus 1 equals S to end, and S dot find X plus 1, S dot end, then that one's okay. So push back, push back X, return answer. Okay, let's see what happens here. 10, 8, 1, 5. Ooh, 3 is there, it's not expected. Okay, so why is 3 there and it's not expected? 3 occurs more than once, okay. So let's do this, right? We can just do a map. Map works. Unordered map. Just to keep the count of each of these things for auto X and A, right? Same thing. And then X count. Then if count is 1. All right. So map M. Initialize that thing. Oops, M dot find M. Okay, that looks good. 1, 5, 8, 10. Come on, come on, come on. I think it's okay. Took a while, okay, but whatever. Okay, one last one. Okay, this sounds like a graph problem to me offhand, right? So there's, what are we saying here? 0 is bad, 1 is good, and then 2 is no statement. Statement sub I sub I equals 2. Statement I, J, okay. So the first person thinks himself as nothing. So 0. Person 1. Wait, hold on. Person 0 states that person 1 is good. Person 0 states that person 1 is good, and then person 0 states that person 2 is bad. Person 2 states that person 1 is good. 0, 1, 2. Person 2 states that person 1 is bad. 0, 1, 2. Person 2. Assuming person 2 is a good person. What? There's 2 types of person. Okay, a good one and a bad one. Okay. Oh, this one tells the truth and this one lies. I see. So maybe you can't trust these guys, right? They might tell the truth and they might lie. So you don't know if they're a good or bad person. Okay, so 0 index 2D integer statements of size n by n. Okay, so basically this is an adjacency matrix. Okay, and then the diagonal column where I is equal to I is always 2. And maybe it's easier if I look at this as a 2-dimensional matrix. Hold on one sec. Just grab this. Okay, this one sounds tricky, but once I found out the wording, I think I can resolve this. Let's see how much time I have left. 1 hour, 17 minutes. We got plenty of time, right? 1 hour and 17 minutes left. Plenty of time to get Q4. She's an elusive creature. Okay, yeah, let's try to tame her. Let's try to tame her. Okay, anyhow, what was I doing? I was gonna stick this thing here. All right, look at it 2-dimensional like. Okay, so here's my diagonal column, right? The diagonal column is always 2 of yourself. Then what is this saying then? Person 0 says person 1 is good. All right, and then this is person 1 says person 0 is good, right? And then this one is saying person 2 says person 1 is bad. Right? Does that sound right? Okay. Okay. Let's take person 2 as the key, assuming that person 2 is a good person. Is that a safe assumption? Is it safe? Safe assumption? that person 2 is a good person? I don't know. I don't think so. Based on the statement made by person 2, person 1 is a bad person. Now I know for sure that person 1 is a bad person and person 2 is good. Why do we know that? Based on the statement made by person 1, since person 1 is bad, they could be telling the truth or lying. Okay, but if they're telling the truth or lying, then that doesn't tell you anything. Okay, it sounds like we need to use some kind of deductive reasoning, right? So it's like graph input of relationships plus deductive reasoning. Okay, so you assume that they're a good person and see what happens. Assume they're a bad person and see what happens. We can see that at most 2 persons are good in the best case, so we return good. Okay, so we're trying to maximize the good people. Is that return the maximum number of good people? Okay. No person ever makes a statement about themselves. Okay. That makes sense. Okay. All right, let me read through this one last time because this is kind of tricky. 2 types of person. Okay, good, bad. Good person always tells the truth. Bad person might or might not tell the truth. Okay, good person, bad person. Bad person 0, good person's a 1. Okay, assuming person 2 is a good person. I guess we know nothing about person 2 because this guy has no opinion about person 2. This guy has no opinion about person 2. So person 2 could be good or bad. It's ambiguous. So we explore both cases just to maximize the amount of good and just to explore and see what happens. Okay, right? So, oh, n is tiny, so we can explore everything. This is huge, right? Let's put a star next to this. Right here, n is tiny. Brute force will probably be accepted, right? Right, just consider all possibilities and see what happens. Okay, so if we assume person 2 is a good person, then what happens? Based on the statement made by person 2, we're going to assume that they are telling the truth. Okay, so there's 2 possibilities for ambiguous persons. Either they're telling the truth or they're not. So explore both possibilities and find out what the best outcome could be of interpreting those ambiguities, right? So he's saying that this guy's a bad person. Person 1 is a bad person, okay? So we're assuming this guy is good, person 1 is bad. So if person 1 is bad, but person 1 says that person 0 is good, then that guy's a liar, right? So take the opposite of what he says. Okay, I think I get it now. Okay, there's some folks which are ambiguous. We don't know if they are good or bad. So these folks, we explore all possibilities. Like 1 if they're bad, 2 if they're good. Then we explore all other, I guess, yeah, all their folks' possibilities based upon the previous assumptions, right, of good versus bad. When someone is good, we assume they are telling the truth about others, good, bad. When someone is bad, though, I assume they are lying about others, good, bad, right? All right, so here we take it at face value. Take it as is, and then this one will flip the bit, right? All right, take it as opposite of what they're saying. Okay. Okay, so if person 2 is a good person, right, and then person 2 says that person 1 is a bad person, we're going to assume that they're correct, and then person 1, if they're a bad person and say that this guy's good, then he's also bad, right? So we're just exploring what they have to say about other folks the best that we can. Okay, so we assume okay, yeah, so I think I see the algorithm, right? So it's basically we're going to do a depth first search, right? Depth first search to explore all possibilities, right? Each ith person is good, bad, right? And then for each ith person, then we explore all their, right? Each jth relationship, right? Recursively explore each jth relationship based upon previous path assumptions of good and bad. Okay, let's code it and see what happens. So we'll use the memo, right? So the first tab will be top down, right, which should TLE, and then we'll add a memo plus memo, and then see if we can turn it upside down. I'd expect that to AC. And if I can turn it upside down, that should AC too. Okay. Let's see what happens. Oops. Do this two-dimensional array for our matrix. Okay, and it's an n by n matrix. Okay. Let's do this. Create a function. She'll capture itself in its own lambda. Go is the name I like to use for my recursive function designation. So we go through each ith person, and then we have to keep track of the assumed relationships thus far. So for each ith person, we want to see if they're good or bad, or we don't know. Okay, so let me grab some more coffee and I'll be right back. I'm gonna think about this, how I want to set this up. But basically, we want to explore all the possibilities for each ith person, assume they're a good person, a bad person, right? Let me just write this down real quick. For each ith person, Assume good and explore, right? TFX explore that possibility or those possibilities, then assume bad and DFS explore those possibilities as well, right? Based on those assumptions, and then keep track of breadcrumbs as we go. Okay, I'll be right back. Yeah. All right. Where were we? Okay, we still got an hour, right? Still got over an hour, so we got plenty of time. So let's just go slow. Remember my mantra, KISS, right? Keep it super simple. Otherwise, I'm going to confuse myself and write all sorts of bugs. Okay. So if this works out all right, I just return go. And then whatever data structure I'm going to use. So I guess the key question that I want to ask myself now is question, what data structure do I want to use for the breadcrumbs, right? Basically the previous assumptions of good and bad people. So I wonder, actually, I'm wondering if this is even a possibility. Is this even possible? I don't know, to do it, sit down. I'm getting a little bit ahead of myself. Focus on the next step, and then the next step will leave to itself for now. Okay, so I want to check the assumptions made so far, right? If it's a good person or a bad person. If there is an assumption, we have to go with it. If there is not an assumption, then we'll explore both possibilities, right? So for each ith person, there exists or does not exist an assumption of good, bad for that person for the current DFS exploration, right? If assumption exists, go with it. Otherwise, right, explore both possibilities. So to know if an assumption exists or not, do we have to go through all the pairs, or yeah, all the other people? I think so. Does there exist an assumption for that person? Yeah, we can just put it in a map, right? Each assumption of good, bad can be placed in a map. Map. So to see what, or do I don't know, do I want to use a map? Use a map or look up in the input matrix? Because we can do, right, we can do O of 1 lookups, right? Right, since A is adjacency matrix, we can perform O of 1 lookups already. Right, so do we need to store that in a map, or do we need to store who's been visited? Let's just keep it simple, right? Keep it simple. And just track who's been visited, right? For each I in 0 to n-1. Okay. Okay, let's start coding. Otherwise, I'm getting into this analysis paralysis state. I'm not going to get anything done. Okay, so using a set, it'll be the set of scene assumptions. Okay, and we can just move this around ephemerally upon the stack as R value reference. Okay, start at the ith person. Doesn't really matter which person we start at as long as we explore all of them. Okay, then I auto scene. All right. Okay. Let's do this. Okay, so if it's been seen, we already know it's assumption about everyone else. I think so. I wonder if there's contradicting information, does it matter? Assuming person 2 is good. Oh, if they're bad. Oh, okay, so there's two possibilities for a bad person. They're telling the truth or they lied. Okay, that's a pretty important thing too. Each bad person has two possibilities. They are telling the truth or lying. I explore both. I want to explore both of these. Scene, and then I'm going to track if they're telling the truth or lying. Right? We have to use a map, I think. Right. So these are the folks that have been seen, as well as the assumption that we're making about them. Telling the truth or they lying? Yeah, it's kind of tricky. Okay, so how am I going to model this then? How's this map going to work? Ith person, and then 0 bad, 1's good, unknown. So in the unknown state, we do have to mark it down as something, right? So unknown will be 0 or 1. Explore both. Right. For a bad person, then you explore all of the bad person's relationships, assuming that they're good, assuming that they're telling the truth, or assuming that they're lying. All right, so a handful of data points to mix myself up on, right? Get out of here, fly. Should be doable if I go slow. I hope. Okay, so if m dot find I. Okay, if it exists, then we've already made an assumption about this person. They're lying or telling the truth. Bad. So entry exists. Okay, so we already made an assumption about this person. So we go with that assumption. Speed the recursively explored jth adjacent neighbor. So make sure to explore the case where it doesn't exist first. Still kind of trying to imagine this like top down, how this is going to work, how this is going to flow, right? So let's go back here, right? DFS explore all possibilities, each ith person from I 0 n minus 1. Order doesn't matter. Just explore them all. Explore each jth relationship based upon the previous assumptions of good and bad. And then assume good. Then we expressly explore each jth relationship, right? And then assume good. This is or bad plus telling truth. Choose assume bad and lying. Right, then we recursively explore each jth relationship based on previous assumptions, right? Do you want to do the previous assumptions or the current assumptions for the ith person? See, this ith person telling the truth or lying, then we know all the other people based on that one person, right? We know all the other people's, I think. I have a feeling I'll have to use paper. I guess it's kind of hard to work this out just typing, talking. Usually I upsolve the Q4 on paper. For some reason, writing and drawing pictures is a little bit easier than typing and talking. Anyhow, this is a pseudocode, right? Explore all possibilities for each ith person, 0 and minus 1 inclusive. Order doesn't matter as long as you explore them all. Assume that they're good or they're bad, telling the truth, and explore all jth relationships. Explore each opposite jth relationship. So this person's lying, so you assume the other about them. And then those would cascade, I would think. I think they would cascade. I don't know, like this question, do these cascade? And then also, what about conflicts? Like one person could be seeing one thing, the other one could be seeing another thing. can we assume that one's lying, the other one's telling the truth, right? All right, the conflict occurs when two people say two different things about another person, right? One person will say that person's good, the other person will say that person's bad. So I guess it depends on previous assumptions too. I don't know if that's a possibility. Is this use case possible? Let's see, 0 says 1 is good, 2 says 1 is bad. Both 0 and 2 are truth tellers. I guess who is more honest? Right? So yeah, there might be some additional ambiguities or corner cases here, which I'm assuming is going to probably trip me up, but we still got plenty of time. Still got 50 minutes, plenty of time to work through it. Let's get something going though. I'm having a hard time starting just because I'm concerned about all the different corner cases down the road, but let's just try to take the next step and then take the next step again and see if I can work through this. Okay, let's just do this. Let's assume good or bad plus telling truth. All those relationships, all those jth relationships. If I is equal to j, then we'll continue. You can't go past, you can't go to yourself. We don't want to consider yourself. Okay, so we're gonna assume good here that this person is telling the truth. Okay, this is the bad plus line. Okay, yeah, just get the skeleton going here, something like that. Okay, so if or a sub I, well, right, you can say each of their inputs is assuming it's true. From the perspective of this person, yeah, I'm thinking probably take a little bit of an offline break and write this down on a piece of paper. It'd be like so much easier. I'll read through this one more time and then probably do that. Based on the statements made by n people, we want to turn the maximum. Let's read through example 2. Each person makes a single statement. There's 2 people. Person 0 states that person 1 is bad. Person 1 is bad. Person 1 states that person 0 is bad. Assuming they're a good person or they're a bad person, that's telling the truth. Person one could be a good person, and they could be lying. Okay. Assuming that person zero is a bad person, right? They're not telling the truth, and person one is a good person, right? Both bad, or it could be lying. Note there's more than one way to arrive at this conclusion. Note there's more than one way to arrive at this conclusion. Yeah, so some deductive reasoning is going on. Okay. Well, I guess, yeah, the key question is how I want to track these relationships and then explore them. All right, so this is if the case where we don't have any assumptions about the right person. Yeah, I don't think I'm memoizing anything. I think I'm going to bottom out the base case here. If m.size is equal to n, that's when we're gonna break. And let's return. So let's just do DFS plus BT without returning anything. And then we'll just set the best at the end. Best will be the maximum. Okay. So here we can just count the amount of people that are good in the map. Best equals, let's do this, candidate, maximum best candidate, and then candidate will be accumulate the map. Nope. Okay, so that'll be the pair input from the map. T plus. Let's do this. Auto x count equals tie pair zero. Oops, I think that did work. Destructure the pair. Oh wait, I'm not X, and then if they're telling the truth or not, right? Good or bad person. Oh, if they're bad, it's 0. If they're good, it's 1, right? Or T plus sims of X. No, it could be 2 though. We don't want a 2, right? X, and then I guess call it state. State. It's 0. I don't know if this will work or not. A 1 or a 2 will turn into a 1. I don't know. State. Like that maybe. It's 1 or 0. So if they're good or they're ambiguous, we're going to assume they're good. I don't know. It seems a little bit off to me. We'll have to work through it. Okay, so TFS plus BT, this thing. If it doesn't exist, then we'll set them to true, or set them to false. If I equals 1, if I equals 0. Otherwise, if they already exist in the map, then we've already taken into account what they have to say. M sub 1, and then to go J move M. Right, so if there's no entry, go do the DFS plus BT. Zero through N minus 1 is what I want to explore. Yeah, it should recursively explore them all. Assume that they're telling the truth. Assume that they're lying. Go through every J item, and then we'll add J one at a time. Assume they're telling the truth, assume they're lying. I'm not even looking at what other people have to say about this guy, right? In A, like the IJ relationships, I'm not even exploring any of these. Yeah, I think I need to do some pre-processing then, right? To say what everyone thinks about this person. Right. I'm totally confused. Okay, yeah, so there's right, obvious problem I'm missing. I'm not even considering the actual input here. A sub I sub J, right? A sub I sub J. I wonder if I need to DFS explore. Okay, can I just do a bunch of loops? Like, right? Maybe I can keep it simpler, right? I don't know. Like, why do I need to wait until the very end of this thing bottoms out? Because it's backtracking, right? I was gonna say do some backtracking. Do I need to backtrack though? Right, so DFS exploration would be useful for backtracking, considering those possibilities. Right, so we couldn't do that in a loop since N is dynamic. Right, is it, or I don't know. I'm totally confused. Yeah, the first three were like super easy, and this one's like kind of just weird. Well, when it's, I don't know, super easy comparatively, I guess, compared to this one. So I guess my first decision, right? First decision is like the overall game plan. One, either we DFS explore all possibilities, backtracking, or two, just do some loops for brute force. Now, either way, either way, n is small, right? It's 15. So we can brute force for AC, I believe. Okay, let's yeah, I'm just kind of like staring at this thing now. I feel like I've stared at this thing for like 30 minutes. So usually when I get to this place, like, yeah, I gotta stop screen sharing and start writing down on a piece of paper. All right, let me work through this and see what happens. Okay, yeah, so it's the ambiguity, I think, that's throwing me off, like the conflicts and things down the road. So I don't know, I didn't record this to sit offline and write on a piece of paper. Hey, we can come back, right? Sometimes it's like you don't see it offhand, but then the subconscious will work on it, and it's like, oh yeah, duh, later on. But yeah, I don't want to record myself and go mute and write on a piece of paper. I'll do that later. I'll upsolve this one later. Yeah, let's upsolve this later. Oops. That's a good learning opportunity. I'm not giving up, but I'm gonna take a break. And then we'll go back and solve these ones, right? Oh, where'd my window go? Eek. There it is, okay. All right, let's solve these ones from scratch and then we'll just post them and then we'll come back and upsolve Q4 later on. Okay, so these are the ones with strictly smaller and greater. So use a map. Actually, let's do this to counter of A. Let's just count each of the values of A. And then let's do return the sum of the elements which occur only once, which are not the high or the low. Right, let's do this. Low, high equals min A, max A, return sum of 1 for x in A if m sub x equals 1, and x does not equal low and x does not equal high. 2, it should be 2 as well. Oh, sum of m sub x. No. M sub x, or yeah, m sub x equals 1. Low is -3, high is 90 for each x in A. Turn the sum. Both strictly smaller and oh, m sub x for x in A if it's not the low or the high. Oh, if I guess we can do this. Low is less than x is less than high. If oh, m sub x for x underscore and m dot items. Okay, something like that. It looks okay. Oops. All right, Python 3. All right, let's practice this in JavaScript and Kotlin. And do we need that, or we just need a counter? Let's just do a counter, right? Got a map. All right, then for x of A, that's the x1 plus m dot get x0. Okay, and then let low equals math.min high math.max turn map for each x we can ignore the count each value x turn map it to okay, so if x is between these low and high, then we'll add it vector x, otherwise 0, and then we'll accumulate the sum using low dash. Okay, there we go. Boom. JavaScript's cool. So C++ I did a little bit different than these other ones, right? So I sorted A rather than just keeping track of the high and the low. Either way it works. No, actually, sort is a logarithmic function, right? Whereas high and low is linear. Let's just do this, right? Auto low high equals min max. Heat up again. Heat end. And I think that's a pair of iterators. So if let me do this, m sub x. So if low is less than x and x is less than high, that looks good. Uh-oh. Oh, dang, what did I do? Min max. I don't need n, min max and then m. Total. I think min max returns a pair of iterators, doesn't it? Min max C++. Oh, it's not a pair of iterators. Oops, okay. All right, just that straight up without the star. Invalid. What? Low is low. High is high. The heck? Is it an iterator? Like, how do you? The heck? Min max, first and second results. Min max element? Uh-oh. What is this? Min max element. Okay, so these are the iterators. Okay, and this is just smallest and largest elements. Make pair. I'm surprised I'm not able to destructure this pair. What the heck? Really? Min max. Min max. Initializer list. What? Really? Yeah, let's just copy and paste this and see what happens. Oh. What? Why is this not compiling? That does work. Min max works. Here, let's do this. Auto A, B, and let's output A, B. And why does this not work? Min max. VI X is, let's initialize it to this thing. X dot begin, X dot end. Okay, it doesn't like it because it's not an initializer list. Like, what the heck? Okay, let's just do min max element then. Fine, that's the one I was thinking about anyhow, that return the iterators. Min max element, right here, and then we'll just dereference them, right? There. That's what I wanted in the first place. Okay. Let's stick this in here, and let's move on. Man, that's taking too long. Okay, how much time do we have left? 13 minutes. Yeah, I can solve these last few ones here. I think I can do them all. I'll do it real quick. Kotlin. Okay. Kotlin. Mutable map of X and A. M dot M sub X equals M dot get or default X 0. 1 plus that. Okay, so the M's is our counter, and then we're gonna do the high and the low. Our low equals A dot min. Let's do this. Low, high, it's a pair, min, max. And then do turn M dot map. Map each of these guys. And we'll say if low is less than X and X less than high, then M sub X. Otherwise 0, right? And then accumulate the sum of that. Whoa. Cannot be applied to transform map. Right, we're going to destructure those things within the map. Low dot qualified call, low dot compared to null but receiver null. Okie dokie, stick that there, that here. Yay, okay, looks good. Woohoo! Okay, this guy's good to go. Let's see. Return the count of each value X of the input array A, where low is strictly less than X, and X is also strictly less than high. Return the accumulated count of each value X of the input array where, there we go. That looks good. Post it here. All right, a few solutions. Boom. Done. Looks good. Okay. We use 2 queues in this case. Alternatingly push them. So that looks pretty good. Pretty decent solution. I'll do this in Python 3. JavaScript and Kotlin. Alrighty. All right, so it's even and odd. We'll have two different queues for each of these. Right, so negative and positive equals dec. Dec, double into Q, right, for each of these. For x and a, if x is less than 0, then negative dot append x. Otherwise, if x is positive, then positive dot x. All right. And then we can construct our answer. Okay. For I in range n, n equals, I think I'm only going to use n once. Think of a. If I is odd, then we'll say ans dot append neg dot pop left. Otherwise, ans dot append positive. Let's do this. Ans dot append. It's okay. Pop left. That works, I think. Looks good. Okie dokie. We'll do the same thing for the other languages real quick. JavaScript. Negative and positive will be our queues. Construct an answer. Show return in the end here. Or let x of a. If x is less than 0, negative dot push x. X is positive. Push on the positive queue. 0, I is less than a length. I and 1. Negative. Oops. And dot push negative dot shift. Otherwise, push on this. Dot shift. That looks good. Not ready. Taking a while. Timer seated. Okay. So this is the O of n squared operation. Right, this guy here. So let's do this. Push. Let's do I don't know if we can do unshift or not. This might be faster to do this. Might not be any faster at all. Push it onto the front, pop it off the back. Let's see what happens here. Might just end up TLing. That's okay. It's like kind of a crappy data structure. Transform an array to do a queue's job because JavaScript doesn't have what it needs to do its job. Okay, well, I mean, that worked. It's just dumb luck though too. Oops, hold on. I'll post my solution here. Try solve it in Kotlin. Our negative and positive equals pair. Let's do this. Arrays of 2. Immutable list. Immutable list. Int. Or actually, we want this to be a queue, right? Let's do a queue. Kotlin Q, look at the Android stuff. Array deck. Q is an interface. That's right. So yeah, array deck might be cool. Array deck. Kotlin array deck. Array deck. Add first, add last. Remove first. Okay. Yeah, should be able to use an array deck. Array deck. So if x is less than 0, do negative dot add. Or maybe push to the front and pop in the back. So remove last. Excuse me. Add first, remove last. Okay. Add first. List. X is positive. First. Or in 0 until size. If I modulus 2 equals 1, then we'll do get our answer. Answer equals list of integers. Turn the answer dot to int array. Water. All right. And dot add neg dot remove last. Else and dot add positive dot remove last. Add first, remove last. See what happens. Looks good. Okay. Okay, yeah, right. Use 2 queues. One for negative values and one for positive values. Then alternatively, I take DQ. Right. Actually, we can make this way easier on ourselves and do this, right? Until n divided by 2, we'll just do this, positive and negatives. Right, alternatively, put them on there. I think that works. Let's see. Clean this up a little bit before I post it. Boom. That we don't have to keep track of I even, right? Not necessarily. It's good. A little bit faster, a little bit more efficient, less to type. All right, so just do this. Pop off each of those. Hold on. Stick that there. All right, make sure this is cool. Uh-oh. What happened? Positive and oh, that's right. 2. Okay, that looks fine. Looks cool, right? It's updated. Okay. Python. Let's do positive followed by negative. Easy steezy. Length of A divided by 2. Right. That's good. Accepted. All right, and then this one. Push the positives first, negatives next. Divided by 2. Use. Oh. There we go. Looks good. Could also check the size, I guess, right? While and neg size. Just pop from them. Doesn't really matter, I guess. To formulate the answer. It's okay. So this one's a fairly straightforward question, right? Nothing too fancy going on. View solutions. Looks good. The lonely numbers. There's once. Adjacent numbers. M equals, hold on. M equals counter of A. And then find all the lonely ones. Return a list of X for X underscore and M to items. If M to X, M to X equals 1 and X minus 1 not in M and X plus 1 not in M. There we go. Looks good. Taking a while. Okay, there it goes. Counter. Yeah, okay. That's cool. Counter. Three. JavaScript. Kotlin. Key. Do the same thing. Use a counter, like a map as a counter. X of A. That's that. X1 plus X or 0. And then let's do Return m.filter. Do this map x count we can ignore, just x filter x m.get x equals soup and not m.get x minus 1 and not m.get x plus 1. There we go. Uh-oh. Need a fat arrow. m.xo and still in Python land. There we go. Looks good. Taking a while. There we go. Okey-dokey. Kotlin's next. Mutable map of integers. Oop. X and A. Of x equals 1 plus m.get. Or let's just do this. How about instead of x question. All right, and then get my Elvis operator on. Return m.map. So each value x, if m sub x equals 1 and not m dot contains x minus 1 and still in Python land here and not m dot contains x plus 1 map x underscore to x dot map it works, right? It and then it. The survey says, expecting an expression. Or did I put too many right parens? No, oh yeah, it is. Okay, so if that, then filter, right? Filter. That's what I want. This one and does the receiver arguments type inference cannot be applied to m dot. What? Oh, do I need to destructure it with this like that? Yeah, okay, that looks good. Yay, okay. Stick this here, and then this is gonna be end. I'm gonna take off. All right, so use a map m to count each value x, the input array A, then filter upon x, which occurs then I guess then return all x which occur once. Whatever. I mean, it's the problem statement. I just use a map. Good enough. Okay, yeah, contest ended a while ago, so Thanks for watching, and I'll catch you guys next time. A few solutions. All done. I'll solve that other one, hopefully, in my own spare time. Okay, thanks for watching. Catch you later.